All right, had some technical difficulties there. A bunch of ads popped up on the screen. Had to get rid of those. So I'm turning part one into two different parts, part 1A and part 1B. So welcome to part 1B. All right, to finish up this image on the slide here, cone cells, rod cells, they have different functions. Cone cells are much more sensitive to color, much more sensitive to fine grained detail. Rod cells, much more sensitive to dim light conditions. They're also much more sensitive to movement. So two different types of photoreceptors, two different jobs. All right, so let's talk a little bit more about sight. When light enters the lens, it gets inverted, which means it gets flipped upside down. So it's actually projected onto the retina upside down. Which begs the question, why don't we see the world upside down? If that's how sensory information is getting put on our retina, why don't we see it that way? Well, this is because sensation and perception are two different processes. Sensation occurs in the eye, which is where it's flipped upside down. Perception, which is conscious, which is when we're consciously aware of visual information, that's where the image on our retina gets flipped right side up again. So we see things the right way up because of our perceptual processes. Now, another example of our perceptual processes having our back is the blind spot. Now, the blind spot is a giant hole in our visual field. And I don't know if giant is very accurate, but it is definitely a hole in our visual field. It's always there, but it's actually very hard to see unless you're looking for it. Now, if you'd like to find it, I have a demonstration you can participate in. Obviously, it's completely voluntary. So if you'd like to find your blind spot, go ahead and close your left eye. Extend your right arm straight out in front of you with your finger pointed straight up in the air. Now do your best to keep your right eye staring straight ahead and slightly move your finger off to the right hand side, just a little bit, not too far. And pretty quickly, well, maybe not pretty quickly, but eventually you'll be able to see your finger disappear. That is your blind spot. I'm doing it right now, and you can kind of move it in and out of the blind spot, see it appear and disappear. If you aren't able to find it just yet, go ahead and pause this video. I know it's not the easiest thing to do, but once you find it, it's definitely there, and I guarantee it is there. All right, so go ahead and pause it if you'd like. Let's move on to the next slide. So what's going on here? This is our diagram of an eye. We've got the lens and cornea here at the front of the eye. Light comes in and it hits our retina back here on the back of the eye. And so this retina is just lined with millions and millions of rod cells and cone cells, our little photoreceptors. There's one particular spot in the retina, right here, and this is where the optic nerve exits the back of the eye. So right here, where the optic nerve leaves the retina, there are no rod cells or cone cells. So if we have no rod cells or cone cells, we can't detect light in this particular part of our retina, which means we can't detect light in that particular part of our visual field. And that's what the blind spot is. It's a part of our visual field where we're literally unable to see because there's no appropriate photoreceptor cells. There's no rod cells, no cone cells. So the blind spot is always there. It's with us throughout the day. Why don't we always see it? Well, this is because of a process called top-down processing. Now, let's talk about bottom-up and top-down processing. So perception can be said to be split into bottom-up processing and top-down processing. Now, these are two different ways that we perceive the world around us. Bottom-up processing is perception that is built on sensory information. So these are perceptions that are built on raw data, incoming sensory data. Top-down processing is perception that is influenced by cognition. It's influenced by thinking, it's influenced by memory, it's influenced by past experience, it's influenced by expectations. It's safe to say we see what we expect to see, and that is because of top-down processing. So, two different ways that we perceive. Remember, sensation is sensory information. Perception is turning that sensory information into something meaningful. So let's distinguish these two a little bit more. Hopefully we can clear up any misunderstanding here, any confusion. All right, we're going to skip that slide. And usually I do a demonstration when I'm teaching this class in person. And what I do is I have half the class put their heads down, half the class keep their heads up, and then I show them these three words here, or three phrases, I guess. Eats fish, swims, pup. And then I switch. So I have people who had their heads up, put them down, and the people who had their heads down, put them up, and then I show them these words. Eats straw, stubborn, nativity scene. So half the class sees these words, half the class sees these words, eats fish, swims, pup. And then everyone puts their heads up and everyone sees this image here. And this is what we call an ambiguous image. It can look like one of two things pretty easily. To some people, it looks like a donkey. Kind of got the ears here and the eyes, the long face. And here we've got the nose and the mouth. And to some people, it looks like a seal. You've got the cute little face of the seal here. You've got the flippers for hands. You've got the flippers for feet. So this is one of those images that can look like two different things. And what we find is that people who are exposed to the donkey-related words, eat straw, stubborn, nativity scene, surprise, surprise, tend to see a donkey. People who are exposed to the seal-related words, surprise, surprise, tend to see a seal. So what's going on here? Well, from the bottom-up processing side of things, you're exposed to the same image, the same ambiguous figure. So you have the same incoming sensory information, but you see something different based on what you expect to see. So those words that you're exposed to will prime you. They will make you expect to see something based on the semantic content of those words. So if you're exposed to donkey related words in an ambiguous image, you'll likely see a donkey. If you're exposed to seal related words, you're likely to see a seal in an ambiguous image. That is the influence of top-down processing. We have perceptions based on expectations. We see what we expect to see. Let's do another one to hopefully clear things up a little bit. So top-down processing also relies on contextual clues to make perceptions. So here we have an ambiguous image. This time it could be the letter B or it could be the number 13. And if you flash just this image in isolation to a person, about 50% of the time they'll say it's like the letter B, and 50% of the time they'll say it's the number 13. But now, if you flash that image very briefly, and it's in the middle of the letter A and the letter C, most of the time they will say it looks like the letter B. And then if you flash that same image, but this time it's flanked by the number 12 and the number 14, they will more often than not say that that's the number 13. Again, same image, but different context. This is a great example of top-down processing influencing our perception, influencing what we see here. So, the contextual clues is another piece of information that top-down processing uses to make perceptions. All right, and let's end it right